when we are looking at our U substitution, basically our U substitution allows us to integrate things that look like f prime of g of x times g prime of x, which should look vaguely familiar. What is that? The chain rule. And so then that allows us to take the antiderivative of that, and we will just end up with f of g of x with r plus c. So our goal is going to be to choose a g of x to set equal to u. And we do have to pick it strategically, which we're going to practice and work on. And the more that you practice picking a u, the better that you get at it. Yes. Okay.
So practice.
Yeah. All of your homework assignments are practices, right? That's why they're important for us to complete and complete in a timely manner, right? Yeah. Alright, so in this case, we have 2x times x squared plus 1 quantity squared. Now, the quantity squared isn't undoable for us to go ahead and multiply out, okay? But, like, if I had something to the, 12th power, would we want to multiply that out? Not really. So, we're getting practice with the squared. That way we can do other things. Now, on ones like this, we have a pretty clear inner and outer function, okay? So what is my outside operation or function? That's in the front, but that does not make it an outer function. The x squared, right? I have stuff being squared. Agreed? But then I have stuff, other things, inside of my square. Agreed? So again, a lot of the times our gx is being put inside of other things. So in this case, we're going to let our u equal the inside stuff. Yes. So then our goal with picking a u is so that way we can rewrite our integral to make it easier to evaluate. So right now, if I just substituted, it's called u substitution. So we're substituting back in what we have. So we let u equal this. I have something that looks like that. Does that integral make a whole lot of sense? Not really. Okay? So right now we have u's and x's, and I still have a dx, which means I'm taking the antiderivative with respect to x. And our goal is to get rid of all of the x's. What does d in the dx stand for? The derivative. So, can I take the derivative of this equation that we set up over there? Yeah, as long as we what?
All of it.
Both sides, right? I gotta do it to both sides. So, what would our derivative of u be? Not u du, because the derivative of u is. What's the derivative of u? So just if I had an x, what's the derivative of an x? 1, right? So the derivative of a u is a 1, but then yes, we have to multiply by a du. So we just end up with 1 times du. We're all okay with that. Okay. So then, what's our derivative of x squared? 2x. And we took the derivative with respect to x, so we're going to put in a dx. Does our 2x dx look familiar? Yeah, why? Oh, okay. Oh, notice that basically now we can substitute that 2x dx is what's going to become our du. Are we all with me there? Now, does just a u squared look like much nicer thing to take the antiderivative of than our original one?
Yes.
Yeah. So if we add our 1 to our exponent, what do we get? 3, and then we're going to divide, and then we have to remember to add our c. Now we do have one more step, because did my original integral have u's in it? No. So we do need to put our answer back in terms of x's. What did we let our u be?
X squared plus 1.
So we're going to substitute that back in for our u. Yes? And if you wanted to, you could check yourself and take the derivative and make sure that we end up with what we started with. Yes, no, maybe. What questions do we have there?
Will we need to simplify it further for multiple choice questions?
No, they would leave it like that. Especially when you have something like a cubed or anything higher than a cube, they're not going to multiply it out. Alright, what about this one? Do I have an inside function and an outside function? Okay. Yes. What's our inside function? Okay, so u equals 7x plus 9. So this time, instead of writing a function thing with both u's and x's, we're going to go ahead and do that whole process on the right-hand side before we start trying to plug in. So what is the derivative of u? The du. What's our derivative of 7x plus 9? 7
dx.
7 dx. Do I have x in my original problem? Yes, do I have a 7 in my original problem?
I'm up there.
No. What do we do?
We can like divide this by 7.
Of what?
The du equals 7 dx.
So we do get something that looks like that. Are we okay with that? So now, instead of just letting our du be what's already there, we are going to have to substitute so we get the integral. We have a 1/7 now, square root of u du. Yes. How might we rewrite that to help us take the antiderivative? I would agree. So if we add 1 to 1/2, what do we get? As a improper fraction.
3/2.
Because then we have to divide by that, which is the same thing as multiplying by 2/3. And again, we have to make sure we add our plus c. But again, what's our last step going to need to be? Plug our u stuff back in. So over here, we're just going to simplify. We get 2 divided by 21 times 7x plus 9. Now to the 3x out. And that would be our final answer. What questions do we have here? What is this? Okay, on this next one, again, we might have to choose our u strategically sometimes. So, what is acting as our outside function on that first one over there?
Cosine of x.
cosine of, extra stuff. Okay, what's acting as our inside function?
5x.
Yeah, so if I let my u equal 5x, what does our du equal?
5dx.
So again, do we have a 5 in our problem? Oh, we do need to move it over with our du.
Makes sense when you say a 5 in the problem.
Yes.
Isn't there a 5 in the side of the cosine?
Yes, but that's getting taken up by my u.
Okay, so you would be saying that there's a 5 outside.
Correct.
With
Like if I had 5 cosine of 5x, then you got an extra 5. Does that make
That
sense?
still would be hard to get out.
No, if it's
Oh,
on
so I
the-
was thinking.
no, if it's on the
and
outside.
then-
Yes, do you see what I mean by like an extra 5 hanging out in the front?
So if it's like 5 plus 5, I mean 5x plus 5 on the inside.
That would still not work because your u would be 5x plus 5.
Oh,
And so if I took the du of it, I still get 5 dx because the derivative of the 5 is just 0. Basically, I need an extra 5 being multiplied on the outside.
the outside of like the inside.
The outside function.
Okay.
Yes. So like for us here on my square root, I would have needed like a 7 on the front of my square root. For here, I would need a 5 on the front of my cosine. Does that make sense? Okay. So now we can say that this is 1/5 cosine of u du. What is the antiderivative of cosine? That's the derivative. Just sine. Yep. Okay, and our u was that 5x. So we get 1/5 sine of 5x plus c. Now, what's different about our next one?
There's more.
There's more. Okay, more what? More things. Okay. So this time, if I did the same thing and made my u equal 5x, okay, I could still say, there's not an extra 5 out there, so I need to take a 1/5. But then what would be the problem? There'd be two u's, right? I would still have a sine of u and a cosine of u. Yes? So that's still not super helpful. So what is our relationship between sine and cosine?
One is the derivative of the other.
Ish. Like, go both ways though.
I said one of them is different.
Okay. Which one?
I mean, cosine is the derivative of sine.
Okay. So do we agree that if we have a sine and a cosine, yes, that it might be more strategic to let our u be one of our trig functions now instead? Do you see what I'm saying there? So which one do we want to let our u be?
Sine 5x.
Does it matter? It doesn't. The only difference between if we let our u be sine x or our u be cosine x is if we let our u be cosine x, you're going to throw in some extra negatives. Now, it will work itself out to be where you end up with a negative, so it's going to come out the same either way. But if you have the option, you can just go ahead and choose the sine, because then you don't have to worry about negatives. Now, what do we have to use in order to take the derivative of that? The chain rule, yeah, which we just reviewed. So, good thing. So, we should end up with a 5 cosine of 5x dx. Yes, because my derivative of sine is cosine. Leave my inside the same. And our derivative of 5x is 5, so that gets multiplied. So, do I have a dx? in my original problem?
Yes.
Do we have a cosine of 5x in our original problem? Yes. Do we have a 5? No. So we still do need to do a 1/5. Do the other side. So now we can rewrite as 1/5 times so let's see, my sine is becoming my u. And my cosine of dx is what's becoming that 1/5 du. So really, we just end up with a u du there. Is u du much nicer to integrate than having two trig functions in our original? Yes. Yes, it is. Do we see how I got that? So why is the 1/5 on the constant? Because it's a constant, and I can pull it out to the front if I want to. It would be the same thing if I put 1/5 integral cosine of du. Nope. It doesn't. Other questions? So yeah, the 1/5 is a constant, so we can put it on the inside or the outside. It doesn't really matter. Usually I tend to do the 1/5 on the outside if I have like u's, because I'm gonna end up with fractions here as well, right? Like things with power rules. Versus with like our trig functions, it's not as big of a deal because we don't use our power rule, right? When we're doing trig functions. Yes? Okay. So what is the antiderivative of u? U squared divided by 2. So 1/5 times 1/2 gives us 1/10. And then what was our original u? Sine of 5x. And that's now being squared. Yes? So we can either write it like that, or most of y'all probably write it as sine squared of 5x, which is also fine. What questions do we have on either one of those? So really the hardest part, I think, is figuring out like what you want your u to be, and then rewriting. Because usually once you've rewritten it, then it's going to be pretty simple to take the antiderivative after that. Because that's the whole point, is to make it simpler for you to take the antiderivative. Alright, what do we have here? E's. Just one E? No, we have a lot of E's. Okay. So as it stands, do we have a clear U? Because notice if I let EU be the bottom part, I just end up, or if I let U be e to the x from the bottom part, I would just end up with an e to the x. So that takes care of one of my e to the x's on top, but like not the e to the 2x. If I let the e to the 2x be my u, or I still only get a 2e to the 2x, and that's not helpful. So sometimes we still need to rewrite before we can try and use our u substitution. So how can I rewrite this? It is a fraction.
I mean, like, make it not a fraction.
How so?
To insert it.
How so?
Like the bottom CX could be to the answer.
It could be, but it would still be being multiplied to the whole thing.
You could divide each part by e to the x.
So we can separate it out. Yeah. because what? Or why?
Just that's what it's doing already, sort of.
When would we not be allowed to do that?
When they're being output.
No.
If it wasn't like a singular variable.
Yeah, if I did not have a monomial in the bottom, right? If we had like more than one thing going on the bottom, we would not want to break it apart. Now, what is e to the 2x divided by e to the x? We have. Now, have I taken my integral yet? No. So does my integral symbol still have to be there? Yes. Okay. Then notice on our second one, e to the x divided by e to the x is just not 0, 1. And so then we're left with a 2 there. And then, like somebody was saying before, we can rewrite that last 1 over e to the x as e to the negative x. Now, can I take the antiderivative of these first two pretty easily? Yeah. What's the antiderivative of e to the x? E to the x. What's the antiderivative of 2? Just 2x, right? Now, what's going on with our exponent here? It's negative. So do we have stuff in our exponent besides just an x? Yes. So what we're going to do on this last one is let our u be that negative x. So what's our du? There you go, yeah. Do I have an extra negative? Oh, so we just need to multiply or divide by a negative. Now, have I taken the antiderivative of my last one yet? No, so does it still need an integral symbol? Yes. Would it be wrong for me to put an integral symbol here at the beginning?
Yes.
Because why?
Because those two have already been.
Because I've already taken an integral of these two. Is it okay for me to break apart addition with multiple integrals?
Yeah.
Yeah, as long as it's addition, we're okay. Adding and subtraction, we can break apart integrals all day long. Multiplication and division, not so much. So now, this has become, let's change this to a minus. Again, a negative is just a negative 1. Okay? So we have negative e to the u du now. What is the antiderivative of e to the u? E to the u. And then, now that I have taken my last integral, what do I also have to have there? Plus c. So the last step, just like always, is to plug that u back in. And so that would be my final answer. What questions do we have there?
So our goal should be to not use substitution until we need to use it.
Correct. Because if it ends up being stuff that I just know the antiderivative of, then I just want to do that because the u sub does take a little bit more time. We will also have some things where we can't use u substitution, so it's helpful for us to rewrite it to kind of see which thing or which technique it is that we're going to want to use.
So, how do you know what to put the u on this one?
Well, my e is acting as my outside function, right? I know what the antiderivative of just e to the x is, right? But I have something besides just x in my exponent. So I need to let the stuff in the exponent be my u. It would be the same thing if I had a 2x up there or an x plus 1 up there. I would need to let my exponent be my u.
And also,
Can you explain how you know to put negative x as u?
Just kind of what he was just saying. So, I know the antiderivative of e to the x is e to the x, right? So if I have something in that form, e to one variable, I know what the antiderivative is. Right now, I have an e to the negative x, right? So negative x is not just one variable. I have a negative up there, which is extra stuff. So just like if I had an x squared, like e to the x squared, or e to the 2x, or e to something other than just an x up there, I have to use substitution for whatever that exponent is. Kind of the same thing, like think about it as the reverse of our chain rule, right? Like I can just take the derivative of e to the x is e to the x. But once I start throwing other symbols, multiplication, other numbers there, I now start having to use the chain rule. Does that make sense? Follow up question.
So, how do you, like, if, let's say you put fish in the wrong view, it just, like, would you get the answer eventually? Just take one steps?
So like basically it's gonna be where it's not gonna work out. So like when I take, so like what's gonna happen is if I take the derivative, so let's say, this first example is kind of easy. So like let's say I let my u be x, right? I take the derivative of that, I get a 2. Does that 2 help me do anything else with the rest of the stuff? No. So then, once I get there, I'm going to be stuck in an integral that has both still u's and x's in it, and I can't move forward from there. So like, you will get a point where it's like, I can't simplify anything else, and I still have u's and x's. So that probably means I picked the wrong u. Kind of, yeah.
Yeah,
Which is
just
what
try
makes
hard.
it fun, yeah. Which is why I said it takes practice, right? The more you practice at picking what needs to be your U, the better that you get at it, okay? But same thing like kind of when we did our chain rule. I'm looking a lot of times for stuff that has insides and outsides, right? So like square roots or like exponents on the outside, a lot of times will have inside things. My trig functions will a lot of times have inside things, okay? Our e to the x, a lot of times the exponent will be the inside thing. So you kind of get better at identifying what the inside part is. Does that make sense?